Hello, welcome to Module 10. We're going to be expanding on Chapters 12, and because it's an expansion in content, since the chapter was not thorough enough on the subject matter of creating power through wind and creating power through water, I have added a compendium file, a PDF that you can read that has greater detail on creation of wind power. So without further ado, we're going to begin talking about the alternative power sources of wind and water, which are indirect derived sunlight power sources. So talking a little bit about wind turbines, this is an image of your basic wind turbine, and you have the rotor, which is the central hub that holds the blades. So these are my blades. The housing body for the equipment is called the nacelle. And then this is your tower, and then of course foundation. To get into this in greater detail, we'll talk about the components a little bit more, all written out in just a couple slides. So I'm going to jump ahead to those slides. So here we go. Here's my rotor. The rotor is the turning system that goes in front of the blades. The blades are pitched, so they're angled just slightly, and that's so that they catch the wind at their optimum potential. And if you are working with a wind turbine system that is a large scale, so one of the ones that would run a community or a small town in that sense, so we're talking about the multi-megawatt system turbines. Those turbines have pitch systems on the blades that will actually change pitch based on the anemometer back here. So the anemometer is reading my wind speeds and my wind directions, and the pitch will actually alter based on those. And that brings me to some of the others. So this is a complex system on my horizontal wind turbine system. And we're going to talk about two types of wind turbine system: horizontal axis wind turbine systems, which are ones where the housing body or the low speed shaft, the one that turns by the blades, is horizontal. And if I turn the low speed shaft to the vertical direction, then we would call it a vertical axis wind turbine system. So we have two big categories, and I'll show you more on those categories in just a bit. So I'm going to give you a little bit more about the equipment that goes in this turbine system. So the blade structure, which is pitched, is attached to a low-speed shaft. This is the one that's going to turn based on the rotations per minute of however the wind happens to be turning it. Then to kick it up to the speeds that I need, I create a gearbox with teething. So I just have a large gear that then connects to smaller gears so that I can pick up through turning this one gear. I can turn this gear multiple times faster, and so I can pick up the wind speed from turning something maybe only 15 times in a minute to something that could be turning well over 1,000 times per minute. So I can change my rotations per minute, or my RPMs, into multi-thousands per minute through the gearbox system within my nacelle. That gearbox goes to a high-speed shaft, which is connected to the generator. And the generator is the magnetic system, because I have my coils within it that allows the electrons to jump, making electricity, because electricity is electrons jumping. So that's basically how we're making this. If I'm working with a very large horizontal axis wind turbine system, I have a component on it that's called the yaw drive. And the yaw drive is in place so that it can turn the nacelle, or the housing body, to face what's called upwind, or into the wind, so that the blades and the rotor is facing the wind direction. So if the wind is coming from here, it's actually hitting the housing body on my system. This is different than small-scale wind turbine systems, which use a tail on the back of my nacelle, and that tail keeps it turned downwind so that the wind always flows up and over the nacelle and into the blades. And so when we talk about horizontal systems, the really big horizontal axis wind turbine systems are things that have a yaw drive and are upwind, where things that are small are going to not have a yaw drive. They might not even have a high-speed shaft that attaches to the generator. They might go right from low-speed shaft into the generator system, and those are going to be downwind systems. These are just statements on those terms from that page, which I have been utilizing in the vocabulary, and I will continue to utilize in the vocabulary as we continue talking about wind turbine systems. And so I'm going to grace over those, and you can take a look. So another big component is just talking about the size and scale of a wind turbine system. And they can go from incredibly large scale systems to things that are very small. So I can go down to something that's just producing a couple kilowatts of energy, so thousands of watts of energy, up to something that's in megawatts, so millions of watts of energy in their system. And this picture right here is the GE model 3.6 megawatt system on that, and that would be considered an incredibly large scale. Here are some examples of a smaller megawatt system. So this is the GE 1.5. This is a Boeing 747, so that you get a feel for the planes. And think of the blades, and so the full circumference of my blade structure is basically my same looking. If I was to take the diameter across, I get that same diameter as a 747 in my blades, which is quite actually small when you compare it to something as large as the GE or repower system, which is a 5 megawatt turbine system. And this is the largest system currently available to the world, and this is the one that they just put out in the lock systems out in Ireland. To get a feel for how big, this is a GE 3.6 system, and these are human beings, right? So I just want you to get a feel for the size and scale of these. They rival skyscrapers in height and diameter. And so here's another picture to get a feel for scale. To take the flip side of that, once again, really quick, popping back, the big scale stuff are the ones that are going to have yaw drives and anemometers. They are going to be upwind, so the wind is coming over the front of the rotor here and sliding over the back of the nacelle. The blades can pitch. You can actually see the gear structure on the blades so that they can pitch to maximize the potential for rotation. And so these systems are much more complicated. The flip side of that is the small scale stuff. This is the stuff that's 100 kilowatts or less. These guys are tiny. These are the ones that you're going to put on your home or a small model or your boat if you buy a mini wind turbine for your boat, so on and so forth. These are the tiny things. These are the ones that we have. We actually have one on WCC campus out in front of the tech building, right? This is a small scale horizontal access wind turbine system. These are downwind systems. So the wind direction is actually coming up over the tail and coming across the nacelle into the blade structure. This, by contrast, works opposite of the vertical axis wind designs. Vertical axis, once again, is based on the low-speed shaft being faced vertically. So I'm on the vertical, where the low-speed shaft on these guys are horizontal. So this is my horizontal axis wind turbine systems. Verticals don't need to have a yaw drive or any component along those lines because they are standing vertically. So the wind can hit from any direction. But there is a lot of lag and drag on these systems. So they kind of can get caught up on themselves. They can even get caught in one direction where if the wind is coming at them, the turbine blades will get stuck. And so they'll actually push up against it and not be able to push one way or the other because the wind is hitting so perfectly balanced on the center part of the turbine system that it's just stuck forward. So there's a lot of inefficiencies. Obviously, if I'm trying to make power for the grid on a large scale, I'm going to want a horizontal access wind turbine system. On the other hand, if I want something small for small use, building something that's a vertical wind access design is perfectly viable. And it's something that we might all want to own for our own personal use one day in the future, right? Just some quick terms again, drag and torque and what that means. And as I mentioned already, I have a lot of drag when I'm using a vertical wind access turbine system. So on that note, I'm going to pick up with part 2. And in part 2, I'm going to talk about vertical axis wind turbine systems, the different systems that exist. And I'm not going to go through the pros and cons. Those I'm going to make you guys self-responsible for when we talk about wind power. So I'll be picking up with part 2 very soon.